Hello, my dear students. Please subscribe our YouTube channel for more free video lectures and click on bell button for notifications and visit our website to purchase full course.
Hello friends, welcome back to the CRT session. So we understood in the last session about the rules and regulations of layered structure like encapsulation and decapsulation, and we also seen some of the responsibilities of application layer. In this session we will continue the rest of the layers responsibilities, and also we see the hardware is playing very important role at the layers. So interviewer also mostly focus on the questions like hub is which layer device, router is which layer device, or firewall is which layer device. So I hope so you also would like to know. We'll see in this session all of them. Stay tuned to us. Just let us see. Now the second layer is presentation layer. It provides presentation form. That's point number one. It implements function call exchanges between operating system and layers. And presentation layer mainly perform encryption or compression and decryption and decompression. And its PDU is PPDU in the form of, as I told you, encrypted message. So what are the real-time applications of presentation layer? WinZip. This is main for what? Compression. While doing compression, we will get lossless compression and lossy compression. So we need to be very careful while doing the compressions. I'm talking some of the compressions here. .bmp, lossless compression. You will get good clarity. Once you do convert to JPEG or GIF, they are going to be lossy compressions because data contrast and brightness will be lost. But anyhow, they are going to reduce the size of the image, no doubt. And the next one, HD format to .mp4 and MKV and FLV. They are lossy formats. So presentation layer is responsible for encryption and compression of data. Other side, decryption and decompression of data. Okay friends, just go with this. Well, friend, now let us see the third one. Session layer. This is a very important layer as far as questions concerned. So as the name implies, session, it is going to create logical sessions or virtual sessions. It creates logical or virtual sessions. Point number 2. Responsible for remote sessions. You talk about remote RIP. So remote sessions can be established using RPC and can be established using RMI. Number 3, PDU is SPDU in the form of checkpoints. Next point, it describes how data conversations are started, comma, controlled and finished. Fifth one, it provides indications whether conversation is in middle or at the end. So this I can tell you like this: 0%, 10%, 20%, and so on. So mainly used in downloads and uploads. Creates checkpoints for successful download and upload. Next one, if at all download is success, it will give you download success, otherwise download failure. Notification messages. Success or failure. Okay friends, these are the responsibilities of session layer. And last responsibility, checkpoints, very important thing. What is the meaning? I have started download 700 MB up to 619 MB success. Here connection lost exactly here. So we have to re-download it. Yes or no? So your re-download starts from 0 or 699. That is from 699. When you use session layer, that is the power of session layer. For every successful download or upload, it creates one checkpoint. Up to that checkpoint, your data will be in the buffer. So when you do the restart or re-download, your download starts from only that particular point only. So therefore, you can able to save a lot of bandwidth. Otherwise, you supposed to download from 0. This is a very important point about checkpoints. Okay, so checkpoints is ultimate responsibility by your session layers. So based on the checkpoints only, you can able to do this restarting of the download from a certain point. What are the real-time applications? Real-time applications are TeamViewer for establishing a remote connections, and internet download managers and torrent. They are for successful download limits and successful upload limits. So this is how you can see that the real-time importance of session layer in the layering structure of OSI. Okay friends, let's copy this. Yeah, well friends, now let us see next layer, that is transport layer. When you talk about the transport layer, it is also end-to-end layer, as we know. Its PDU is segment. That's nothing but TPDU only. Segment size is restricted. (65 536 bytes at a time). Next point is interface. Upper layers and lower layers. Next point, It is port to port based, mainly deals with the port address. And the next point is its responsibilities: segmentation, next one error control, flow control, next one congestion control, and the next one muxing, buffering, pushing and pulling, timers. These are the responsibilities of session transport layer. Some responsibilities are also common to session layer. If I am taking a session layer, as I told you, checkpoint is one of the responsibility. And flow control is one of the responsibility commonly. And here dialogue management or dialogue control, next one is, so here the flow control is common here. This and this is going to do the flow control concept. And as we know, remote connections. So this is how about transport layer. Okay friends, let's copy this. Yeah, well friends, now let us see network layer. So when we talk about the network layer, it's also called as internet layer. What is an idea? Very few points we'll see. It is host to host based. It's very important. Next point, its PDU is an PDU in the form of packet. And the next point, packet is limited size. And the next point is it deals with hardware media. And the next point is some of the responsibilities. First one, packet construction. Next one, routing. Next one, IP addressing. This is very important. Next one, congestion detection and prevention. This is how about network layer. And the next layer is data link layer. What's the data link layer? It is hop to hop, link to link based. Number two, come back to its PDU. In the form of frame. Next one, frame size is limited. That is 64 bits to bytes to 1518 bytes. Next point, it also deals with media. And responsibilities. Number one, frame construction. Number two, error detection and correction. Number three, flow control and error control. So this is how about data link layer responsibilities. In this, the very important hop to hop, and here very important host to host. Just copy this. Well friends, now let us continue. The last layer, that is physical layer. So when you talk about the physical layer, it is involved in actual transmission. You can say it is interface to media. Very important point. Interface to the user is the application layer. Interface to the media is physical layer. It deals with physical characteristics of the media. It deals with the physical characteristics of the media. Its PDU is PPDU in the form of bits. Bits are also limited, depends on bandwidth. So, what are the responsibilities? The responsibilities are bit to signal and signal to bit conversion. This is a point number 1. Point number 2, identifying media, whether it is wired or wireless. Point number 3, identifying topology. Already we discussed about topology. Next one, identifying communication mode, whether it is a simplex or duplex. Next, identifying switching. Transmission technology like unicast, multicast, broadcast. Next, identifying transmission mode, parallel or serial. Next, identifying switching technique. Circuit switching, message switching, packet switching. That's it friends. This is how the layers are, it deals with node 1, node 2, node, And as we know that data transmission is done vertically and data communication is done horizontally. Okay. Yes, we copy this. Now we will discuss about hardwares at different layers. Yeah, see friends, now you observe carefully the following is very, very important for campus interviews concern. There are some standard devices which are mainly plays important role during data transmission. They are hub, switch, repeater, bridge, router, firewall, gateway. These are very, very important questions. And being a computer science student or EC or any person who want to enter into communication field supposed to learn about these devices carefully. So, as I am talking about the repeater, where will you keep the repeater? This is a layer 1 device. Whenever I am saying a layer 1 device, it's associated with the physical layer only, right? So what is the role of repeater? It is a 2-port node. Like this only repeater looks like, which take input cable, which gives output segment. So regeneration, that's the concept of repeater. What is the main motto? It's not a connecting device. It's not a connecting device. It is only used to extend the LAN. Extend the LAN segment. How? For example, node 1 and node 2. Far away, both nodes are far away. So how will you establish the connection? Maximum twisted pair distance is 500 meters. So we want to extend from 500 meters to 1 kilometer. How it is possible? We will take care of repeater now. This repeater will take care of another repeater. This repeater takes care of another repeater. Assume this can extend up to 500 meters. This can extend up to 500 meters. This can extend up to 500 meters. And finally, you can able to communicate with others. So you want to extend a network. So attach the input cable and you try to extend the LAN so that with the help of repeaters, the distance of the network can be expanded. So advantage is so fine, but what is the disadvantage? Every repeater generates 2.5 microseconds delay. This is an important point. So I cannot have n number of repeaters. Maximum repeaters are 3. Okay, this is how about repeaters. What is the use of a repeater? If you place a repeater, the distance between node and node 2 can be increased. Therefore, node 1 to repeater 1 500 meters, take the repeater 1 to other repeater 500 meters, from that repeater to other node 500 repeaters. Therefore, you can able to enhance your network capability. Okay, copy this. Yeah, next we see second device, that is hub. So when you talk about hub, it is a connecting device, LAN forming device. Repeater is not a LAN formation device. Repeater is try to extend the LAN segment, that's it. But when you talk about a hub, it is LAN formation device. That means several nodes nodes can be connected to hub. And the next important point is hub is passive and active. There are two varieties hubs. Hub is not an intelligent device. Default hub is passive. And the next point is hub has only one collision domain. Even though it has endports. Next one, hub does not maintain MAC tables. It does not deal with any addressing. That's why hub is not an intelligent device because of the above reason. It doesn't know who is sender and who is receiver. Hub is multi-port repeater. Hence, hub is broadcasting device. So what is the meaning? Just look at this. When you take hub 1 and 2 and 3 and 4, whenever one transmit the data, source IP is 1, destination IP 4. But what hub will do, it doesn't know who is 1 and who is 4. Therefore, what is going to happen? It try to hand over data to each and every port. That's why it is known as hub is a broadcasting device, and it is a repeating every port. That's why it is called a multi-port repeaters. Okay, friends? Copy this. So hub is which layer device? Hub is layer 1 device. Yeah, well friends, now let us look at into switch. So what is the meaning of collision domain? Collisions are confined. Collisions are confined. Now if you talk about the switch, switch is intelligent device. Why? Because it maintains MAC tables. Can identify who is the sender, who is the receiver. This is a specialty of switch. It is a layer 2 device and maintain MAC address. It deals with MAC address. So switch increases collision domain. So here there is an important point that switch has 10 ports. How many collision domains? I can say answer as what? 10. If it is in the hub, it is only 1. Next point is switch is also LAN forming device. So when you talk about a switch, which is also consisting of some points and nodes are attached to that, 1, 2, 3, 4, and this switch maintains MAC table. This table consists 1, 2, 3, 4, and every node MAC address it will maintain. So based on that, whenever I say source IP is a 1 and destination IP is some 4, then data just will be handed over to 4 only. That's why switch is for 1:1 communication. Okay friends, this is how the switch exists at layer 2. Layer 2 is nothing but data link layer. Okay, copy this. Now you see, as we have observed the difference between hub and switch, both are trying to perform same task, but unfortunately hub is not a successful one. Why? Because it is not able to identify who is the sender and who is the receiver. That's why switch is very famous than the hubs. And another question I want to ask you here, if n ports in hub, then how many collision ports or collision domains? Now you can say the answer. How many, friends? It is only one. Why? Because hub itself is acting as only one collision domain, but in switch it is n collision domains. Okay. We will see the rest of the hardware devices which are playing at the different layers in the next session. Stay tuned to us. Thank you.